ARP is used to map an IP address to a physical MAC address. In the exam, they could swap this definition around and try and catch you out. Welcome to the Cisco CCNA Cram. This is version 6. It's been going a few years. So please memorize everything that's in this Cram guide. If you watch the video for a while, I'll put up a link so you can download a version of this that's been professionally formatted. This is just my draft version. So before we start, just to let you know, you can get the syllabus for the latest version of the exam if you just Google Cisco CCNA syllabus. Please note, it's a 120-minute exam. The important thing is the following topics are general guidelines for the content likely to be included in the exam. Other related topics may also appear. So if I've missed anything off, or if you read a book, including my CCNA book, Cisco are at liberty to add things that aren't listed here. So please bear that in mind, because I sometimes get emails from people. So they're allowed to add things. For example, EIGRP isn't listed, but in the past they have added questions. So just bear that in mind. So this entire Cram syllabus, Cram guide, must be memorized by heart. Again, watch the video, but there's also be a printable version. So we'll skip through. There's a syllabus obviously here, or an index, sorry. The best version is, I've got a website, sorry, howtonetwork.com if you're interested in learning online. 101labs.net is for people who just want to do labs, and there's a 60 days program. These are my CCNA books if you're interested. CCNA in 60 days, CCNA Simplified, and Hands-on Labs for the CCNA. All right. Oh, it's copyrighted. Please feel free to share this with your friends, but you can't copy it, change it, and pretend that you wrote it. All right. The entire contents of this guide must be committed to memory before attempting the exam. It's not a brain dump. I don't know what's in the exam, so you could be asked stuff that I haven't listed here. This is just my best effort to give you the best information possible. All right. So network fundamentals will match the order of the syllabus. There's a difference between the physical layout of your network and the topology locally. So the physical layer is what you can actually see. If you go into the server room, that's supposed to be somebody's eye, by the way, you will see a bus topology, which is devices connected to a cable, or it could be a star with a switch in the middle with devices, or whatever. It could be any of these. Logical is what the network sees. So the network sees something different to what you may see. And you need to know the differences. Firewalls, these filter traffic into and out of your network, usually positions at the network entry points or between critical modules. Now, most firewalls operate at layer 4. You can get a whole bunch of different types of network. It's based on the UDP or TCP port numbers. They can operate at layer 7. These are called next generation firewalls. Cisco mentioned these in the syllabus. The first generation of firewalls provide you just basic capabilities, and obviously the cheaper ones at layer 3 and 4 of the OSI model. We'll come to this later. Second generation, layer 3 and layer 4, layer 5 also. Third generation, 3, 4, 5, and 7, and so on. A stateful firewall can track, for example, the number of connections to a web server per second. If it's stateless, it doesn't have the capability to make decisions based on historical data. So stateless firewalls just watch real-time network traffic and block based on static values. You need to know the difference between an IDS and an IPS, again, because it's in the syllabus. IDS and IPS provide perform traffic inspection, detect unauthorized traffic that tries to enter the enterprise network. The major difference is that IPS operate in line with the traffic, meaning they're placed in the middle of the traffic flow. IDS only retrieves a copy, so they will look at the traffic later on. Routers, I'm sure you've heard, these are a directory of networks. If you just wanted to summarize what they do, they don't concern itself about end devices like PCs. They store a list of networks. Switches operate by building a list of which PCs are connected to which ports. I say PCs, it could be just any end device, so PC servers, whatever. If a PC wants to send data to another PC switch, the switch will forward the traffic only to the port to which the extended recipient is connected. If it doesn't know the port, it sends out a broadcast. Routers do not send broadcasts. Layer 2 switches operate at the OSI data link layer using the MAC addresses. Layer 3 switches combine Layer 2 functionality, but they can also look at IP addresses. They can also have simple ACLs, access lists, and routing protocols. Just depends how much money you have. Wireless networking, they use carrier sensor multiple access with collision avoidance. In the exam, they'll try and trick you by saying collision detection. These don't. These use collision avoidance. These prevents the wireless frames from colliding. There's a centralized hub called the Wireless LAN Controller, the WLC, which is like the brains of the outfit. Access points are used as hubs to transport signals across the network. So I've already mentioned the CSMA-CA replaces CSMA-CD, collision detection, which you have on LANs. Power over Ethernet as a technology that allows switches to pass electrical power along with the data on Ethernet cables. Now, there's 4 extra wires used in order to achieve this. They're not used for the data transmission. Power over Ethernet is used to power non-critical network devices. You can use IP phones on it, video conference, surveillance, and wireless access points. You have to have a special switch model, so not all switches support power over Ethernet. OSI model has been tested since time immemorial. It's a 7-layer way of looking at all IP networks. And each layer are basically broken down what the function is. So it starts at layer 7 and then works its way down. This is how we describe it. And then each one has a function. And I've also listed the services. Down here, I've listed the devices if there's applicable. Obviously, if you've got a layer 7 firewall, it would be sitting up at layer 7. So it goes application, presentation, session, transport, network, data link layer, and physical. And in the exam, they will have a list of what these do. For example, which layer establishes end-to-end connection, and it will ask you which layer, and obviously you will drag and drop if that's the type of question. Over to the transport layer. How do you remember all of this? You basically use a mnemonic. All people seem to need data processing, application, presentation, session, all the way down here. Data formats at these layers, basically how the information is encapsulated. First 3 layers are all data. Then transport layer is a segment, packet, data link is a frame, and then bits. So don't some people fry bacon. And I've explained in the Cram what each layer does. So you can pause the video or download the guide and have a look yourself. There are questions about the Cisco design network model, which is different to other vendors and maybe any network design you've studied. So the Cisco hierarchical model, generally broken into 3 layers: the core, the distribution, and the access layer. Down here is closest to the user, and up here is closest to the internet. So this is generally what you would see, and each layer has basically got a main function. So fastest here, wire speed data transfer, down here connecting the user. Depending on how big your network is, you can actually collapse it from a 3-layer down to a 2-layer. So if you've only got a few devices, you would do something like this on this side. I've listed what the function of each layer is here. Cisco have also added Spine Leaf to the syllabus. So Spine Leaf is aimed at data centers. that quickly need to move data on a massive scale. So this is going to be different from your business network. This 3-tier model that Cisco come up with for corporate networks isn't going to work. Devices in a spine leaf are always exactly the same number of segments away, provide consistent latency for traffic. So every leaf switch is connected to every spine switch in a full mesh. The easiest way to see this is to look at the image, and you can see every device here has got 4 connections, and every device here has got 4 connections. So you've got a full mesh topology. Again, this is for data center. Huge amount of the CCNA covers TCP/IP, and you need to know all of these port numbers. So you need to match what each one does with each service, and you need to roughly know what each service does, and if it uses TCP or if it uses UDP. So they may have a question saying, what is TFTP, and what's the port number, and also is it using a UDP, TCP, or both? So unfortunately for you, you need to remember them. The list is only about 15, so it's not too bad. Possibly asked what protocol number TCP and UDP use, and now you know. Brief description of some of the common TCP protocols and ports. I've put an output here. I'm not sure why I did it. I'm guessing it could have been an exam question. The traceroute command. Just bear in mind you need to know on Cisco what the command name is. On Windows, it's tracert, I think. So they might try and catch you out, and you can see the type of output you get. ARP is used to map an IP address to a physical MAC address. In the exam, they could swap this definition around and try and catch you out. If you want to see a ARP table on your router, then it's show ARP, and it will show you the MAC address, the IP address, how old the entry is, and the interface it learned it from. DNS resolves host names to IP addresses, not the other way around. You can configure your router to be a DNS server with the command IP name -server, and then the IP address of the name server. Try all these on a router, by the way, and on Packet Tracer if you can, if it supports it. What DHCP does, central server, which relays TCP information, not just IP addresses, but some other TCP information. These are the commands to configure your router as a DHCP server. Sometimes you would do that if you don't have a DHCP server or your DHCP server goes down. So try these commands again on Packet Tracer. DHCP relay is a new topic in the syllabus. I think it's a new one. I don't remember seeing it there before. If you want your router to pass on DHCP messages, they're broadcasts. And remember, routers drop broadcasts, I said earlier. You will configure this command, IP helper address, and you will tell the router which IP address to forward these broadcasts on, and they'd get turned from a broadcast into a unicast. Network time protocol, again, that's in the syllabus. Gives a time to devices, so they all agree. This is the command you would add to a router to designate your NTP server. And then if you want to see any associations, you'll put in this command here. You can set your router as the NTP server. Don't normally do it, but you could be asked. The router's got modes. So looking at the output, when you configure a router, you'll see the greater than, user exec, privileged exec, global configuration mode. It says config. When something's gone wrong, it could be in Roman mode. A setup mode is a series of yes or no questions that the router will ask. You'd never use this in real life. And then RX boot mode. Again, there's been a problem. This is a favorite. It's not in the syllabus, but it's a favorite in the exam. There's basically shortcut commands that you can use on your keyboard to navigate when you're configuring. So, for example, if you're configuring a line of config here, if you press Control and W, it will erase a word. Controlling U erases a line. Control and A would take you to the start of the line, and so on. So practice these on a Cisco router. And there's a few more. If you're typing out a command configuring a Cisco router or switch, and there's no other options that begin with RU, if you press tab, it will finish off the command for you. Hit the question mark. This works in the exam. So you think copy and you can't remember the rest of the command. The router will list all of the available commands that start with the word copy. If you don't remember the name of the command at all, but you know it begins with a certain letter, you can type the first letter and then question mark. All right, cabling. You basically need to know when to use a crossover cable and when to use a straight through cable. So these are the instances. For example, if you're connecting a switch to a PC or a workstation, then you would use a straight through cable. So I'll just put down here the pinouts for Ethernet cables. So if you don't have a switch, you would use a crossover cable. So say you wanted to connect a PC here and a PC here, you would use a crossover cable, and this is what the pins would look like because you don't have a switch in the middle. Straight through cable is your classic cable for Ethernet networking, and you can see each number matches. Rollover is you're connecting your PC to the console ports or auxiliary ports on a router, and everything is swapped. So 1 goes to 8 and vice versa, 8 goes to 1. They do ask a bit about interference or troubleshooting. Crosstalk can occur on twisted pair cables when the data gets corrupted. There's near-end crosstalk and far-end crosstalk. You can change the speed and duplex settings on your Ethernet. It's normally set to auto. Sometimes this causes problems, so you may need to hard set it. The command show interface, and then whatever your Ethernet or fast Ethernet interface is, and it will basically tell you here what your duplex setting is and what your speed setting is, and if somebody's been messing around or you need to hard set it. And these are the commands. Again, do these commands on a router in Packet Tracer. This is the command to change the duplex. If you need to console into a router, these are the settings. Again, these are classic exam questions. So you'll maybe have an image with different values in here, and this is what you would need to configure. CDP, LLDP, Cisco Discovery Protocol. This only runs on Cisco devices. So this is your classic exam question. It gathers information about other routers and switches. Very handy for troubleshooting. And show CDP neighbours. If you're from the UK, it's note the spelling. There's no U. We have a U in the word neighbours, but you don't have that because it's American spelling. If you want to see more detail, you can add the detail switch on the end, so show CDP neighbours. So connect some devices to your router or switch, and then issue this command in Packet Tracer. You can disable, this is a classic exam question, if you want to turn CDP off for security just on one interface, it's no CDP enable. If you want to disable it completely on your device, no CDP run. There's LLDP, which is the open standard version of CDP, IEEE standard 802.1ab. It shares many of the same commands, disabled by default. The command to enable it is LLDP run. You can disable it per interface also. So LLDP transmit, LLDP receive. So you could, if you want to disable it, you type this command out with no in front. Hex numbering is tested in the exam. You may need to convert binary to hex, hex to binary, decimal to either of these two. Decimal is a 10-digit system. Binary has 2. And so 10, 2, and hex is 16. Hex is like a compromise between these two. So we could sort of understand it easier than looking at a long binary number. So, as I said, it's a base 10, a base 2, and a base 16. So, for a decimal, we'd go the ones, the tens, 100s, 1000s. In binary, if you add a 1 to each binary column, it goes 1, 2, 4, 8, and keeps going up, obviously, to infinity. Hex is 1, 16, 256, and 4096. You can see for each successive column from the right increases values. For decimal numbering, it's multiplied by it's 10 multiplied by 1. For binary, it's 1, and then 1 multiplied by the numbering system of 2. So the easiest way is to look at counting from 0 to 15 in each of these systems. Obviously, decimal is easy. Binary, we just keep adding ones to the columns. So that's a 1 in the 2 column, or 1 in the 1 column and 2 column to give us 3, and so on. Hex looks fine until you get to the number 10, and then it switches to A, B, C, D, etc. So these are the only possible values for each of these counting systems. Hex, unfortunately, you'll need to know because of IPv6 and also MAC addressing. Originally, the IP addresses range was reserved for use by any person or companies who needed them. This is to save IP addressing space. These addresses can be used on your home networks. In fact, they probably are used, or corporate. They can't be routed on the internet. So if any of these addresses you try to get out to the internet, it would get dropped either by your device or by your internet service provider. If you want to test TCP IP is working on your network card, for example, you would ping the 172.0.0.1 address, and that would ping itself. IP addresses were put into classes, no longer strictly relevant, although it could pop up in a exam question. So there's typically 5 classes of IP address: A, B, C, D, E. E is for experimental. You'll only see D for multicast traffic, which is video conferencing, or OSPF, for example. And then we've got class A, B, and C for our networks. Your class A has got a network, a number, and then 3 hosts for the next 3 octets. B is network, network, host, host, and then C is network, 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 and then host. The network address is signified by the 255 here. So you can see the ranges, so you basically just need to remember these numbers for the exam. Typical network traffic: unicast, data sent to one device; multicast, sent to a group; broadcast we don't want, it's sent to all devices; collision domain is all devices that share the same bandwidth, and collisions are separated by switch ports now; and a broadcast is any device that would receive a broadcast message on your LAN. Subnetting, basically, to work out your subnetting, your max number of subnets is 2 to the power of mass bits. The max number of host address per subnet is 2 to the power of mass bits. We'll go through this in a minute. So easy subnetting. In the exam, they would typically say something like, which network is host address 172.16.5.68 on, if the IP address is 255.255.255.240. So typically your class B address would just have these 2 octets filled in. We've stolen bits from the 3rd and the 4th octet in order to make subnets. So the easiest way to do this in the exam, and I'll show you a book you can use, is to take the last number away from 256 and see what value is left. So the last value here, take away from 256, gives us 16. Our subnets will go up in that increment. So our subnet will be 172.16.5, start off at 0, then add 16, and then add 16, and add 16 again, just keep going. I think I might have actually had 16, 38, 48. I may have missed one in the middle here, sorry, but keep counting up in 16s. I'm looking for the network that's got host 5.68 in. And it's this one here. And again, I'll go into more detail actually in a book. I'll give you a link in a minute. So this is my super subnetting chart, my subnetting cheat chart. Before you say you've seen this elsewhere, I wrote this in 2002, so 23 years ago, and I didn't see it before that. So other people have used it or altered it, which is fine, but this is when I first came out. So have a look on my YouTube channel for IP subnetting, where I explain how to tick across, how to tick down to find out how many subnets, what your subnet address is, and what your count is to get the correct IP address. So I think I'll leave you to read that in your own time. But this is the book. It's on Amazon at the moment, Amazon bestseller, IP Subnetting from Zero to Guru. It's on Kindle and printed. If you already know subnetting and want to drill it, then this is the book to get on Amazon. Route summarization, you could be asked about this. Basically, you're given a list of network addresses, all of these, and what they will say is summarize, advertise one address out of your router that will say that all of these are available inside your network. The easiest thing to do is write it out longhand, unfortunately, and then count how many bits match. So until you run out of bits that actually match, and I've done these as italics. So all of these bits match 00001, 00001, all the way through, but these numbers change. So you can see they stop matching after I get this far. So basically 8 bits, so 16, and then 5 bits here. So we've got 21 bits that match. So what you would do is find the lowest address, so 172.16.80, and then add a 21-bit mask, which is here. And that's how you would basically do your network summarization. VLSM is basically variable length subnet masking. You've got one large network, and it doesn't work for you for a number of reasons. So what you can do is divide your network into smaller portions. So network 1, 2, 3, and 4. This is just the easy way of looking at VLSM. So say, for example, you are managing this network 200, 100, 100.0, and your boss or whoever says you need the company's expanding or splitting, and you need to divide this one big network into 2 networks. So you've got this /24 mask, and if I instead add the /25 mask, this has carved it down into 2 smaller pieces, and you would use your subnetting secrets chart up above to work this out. Basically, this is what your third octet is doing, and you can have 2 possible values for your fourth octet. If you add this subnet mask, this VLSM mask, you basically go from 1 subnet to 2, and then the first subnet would start with 0, the second subnet would start with 128, and each would have 126 hosts instead of 254. Again, I'll cover this in more detail in the Subnetting Secrets book. This is just a cram guide rather than teaching you how to do it all. IPv6. So we basically were running out of IP addresses, and this was the solution to expand our 32 binary bit address to 128 bits. Every 4 bits for this 128 bits is represented as 1 hex digit. So this is why we need to know a bit of hexadecimal. If you wrote out the hexadecimal in full, then you would see each octet of each part of the address has got 4 bits, and it can be anything from all the zeros to all the Fs. And remember, 0, 1, 2, 3, A, B, C, D, E, F is the last value we can have for hex. IPv6 address consists of 128 bits. It's in hexadecimal format, and we break it into 8 parts, like you can see above. So this would be an example of a IPv6 address. Obviously, impossible to remember all of this. There's no broadcast, there's only anycast and multicast. The three ways you can represent an IPv6 address are the preferred or complete address, so write the whole lot in full. You can have a compressed address, which you can be tested on the exam. You can put an IPv6 address inside an IPv4 address. The IPv4 address is embedded inside in case you've got both running on your network. The preferred representation is just the entire address. Compressed, there's a couple of rules, but basically you can squash the address down so it's easier to write out and easier to see. First method, you can use a double colon to represent consecutive zeros. Okay, so they all have to be together. Second method is to take the leading zeros and remove them. So leading zeros are at the start of an address. If it's at the end of an address, these are trailing zeros. It's the leading zeros you can remove. So a couple of examples here. This is the full address. If you wanted to write it out in full, you can see all of these leading zeros here. They're all consecutive, so you can just represent it. You're only allowed one of these double colons here. And then here you can see the leading zeros here have been removed, because if you write out the 4, the router understands that it's got leading zeros in front of it. I've got consecutive zeros here, so I'm allowed to use one of these double colons. So that's the general rules. You can't have 2 of these colons in a summarized address, and you can only remove the leading zeros, not the trailing zeros. IPv6 address types, you link local, site local. This is depreciated, so it might not be in the exam. Aggregate, global, unicast, multicast, anycast. It's got a loopback address and unspecified. So here's the definitions if you want to pause the video, or just look on the Cram guide if you download it. Loopback addresses are using the same manner as IPv6. And I've already mentioned about the colons. IPv6 uses Neighbor Discovery Protocol. This is basically the plug and play feature that does a lot of the jobs that you would normally have done with IPv4. NDP works in the similar way to ARP. So it replaces ARP and the ICMP router discovery. These are the ICMP version 6 type of packets: router solicitation, advertisement, neighbor solicitation, neighbor advertisement, and router redirect. Yes, you might need to know these, unfortunately. I've added a diagram here in the Cram guide. Just jumped over to my Cisco CCNA book here. I just wanted to talk about EUI 64 because it can get complicated, and then I'll jump back to the Cram guide. So EUI 64, it's a cool feature that allows automatic IP, or helps with IPv6 automatic address assignment. But what it does is it takes the 48-bit MAC address. Now, the 48-bit MAC address isn't long enough to make an IPv6 address. There's not enough bits inside it. So what it does is it converts the 48-bit address into a EUI 64 address. So if you take a MAC address, for example, I've issued a show interface fast Ethernet 0/0, and it showed me my MAC address here. So please do this on your router or packet tracer or whatever. It does a couple of things. It adds in the middle a FE. So right in the middle of the address, if you can see, it goes 11AABB, or down here 11AABB, and then if we show the interface here, 11AABB, and in the middle is the FE. So it's been inserted by the EUI 64 addressing scheme. So that's one thing it does, but it's still not enough to make the EUI 64 address, what it does is it very quickly converts the hexadecimal to binary, which is why we need to know how to convert hex to binary into decimal. It inverts the 7th binary bit. So if I wrote out these 2 bits here from hexadecimal into binary, it would be 4 zeros and then 4 zeros and then 4 zeros. And if you count across 7, it flips this bit here. Now, when you convert it back, then you will see it changes one of the bits 00000100, and as I write here, it's a 02 in hex. So now you can see the address here is 0011, and it's changed to 0211. Obviously, the leading 0 has been removed because the address has been shortened. All right, so here we go. It pretty much says the same thing on the Cram guide, but I just wanted to jump over to the full CCNA guide to make it easier. You need to verify IP parameters for your client operating system, and you need to know how to do it in Windows, Linux, and Mac. In Windows, you can use the GUI, obviously, so you can go to your settings and then click on IP configuration settings. On the command line, you type CMD in the little box to pull up your command line. You'll issue the ipconfig command that gives you your basic IP addresses. If you want more information, it's ipconfig /all. For Linux, this command has or has been depreciated, ifconfig. So now the command is IP address show. For Mac, you go to the GUI, you go to the system settings, which is the little gear icon, and then to network, and you'll be able to see there. They don't really list WAN apart from design. I've just put a couple of little facts about wide area networking for your serial interfaces, just in case you get asked a question. VPN is an encrypted network transported over a public network, for example, the internet. VPN carries private data over a public network using advanced encryption and tunneling methods. So quite a few advantages to it. You've got some tunneling protocols available. They do ask about site-to-site or intranet VPNs. You would use these when you want to connect to different locations over a public infrastructure. This is when using a peer-to-peer infrastructure. Remote access VPNs, for example, virtual private dial-up network, is the approach for a VPN that's normally done with security in mind. Cloud computing, there's 3 main types: software as a service, platform as a service, infrastructure as a service. I think really that's maybe all you need to know. There's some examples of software as a service, platform as a service, like the Google App Engine. Infrastructure allows you to run many applications in the cloud instead of using your own infrastructure. Private clouds are your own private network in a cloud, as the name suggests. Normally uses virtualization, operates just for your organization. Got some definitions of community cloud and public and private. Again, just in case it comes up in the exam. Virtualization is a new item for the syllabus. You've got a single physical device on top of which you use virtualization software, and this can create virtual machines inside the physical device. You've got hypervisors they could ask you about. A type 1 hypervisor, this is installed directly onto a physical server, often heard the term bare metal. And type 2 or hosted hypervisor runs on top of an operating system. Server virtualization uses hypervisors to abstract and partition a physical server into multiple isolated VMs. Containers in the syllabus, lightweight portable virtualization units that package applications and the dependencies to run together. Wireless networking. If a wireless LAN controller is introduced to the network, the access points, which are like your wireless hubs but can be smarter, they no longer act as an individual device storing any information. They become what's known as lightweight access points, or LWAP. I mention this in case they ask you what it does or why that would happen. Your wireless LAN controller then takes over the roles that your access points or your wireless hubs were doing. Every mobile device will join a wireless network. It's identified by a service set ID. You'll have seen these at home on your wireless network, which is normally automatically given a name. And if you're scanning for a network, you'll obviously join your own service set ID. Three main types of wireless frames: data frame, management, and the control frame. This is important. I'm not going to say why, but you need to know the 4 levels of quality of service. It's unfair because unless you buy a wireless access point from eBay secondhand, you won't see these options because Packet Tracer has got very limited GUI, so you won't see these. So basically, learn the levels of quality of service for how traffic is divided for the Cisco wireless access points. I won't say any more than that. The types of wireless security, WPA, this is actually not used very often anymore because it's been replaced by WPA2. Have a look at what the encryption is used, like TKIP or AES, and then WPA3, because they might ask you to do a mix or match. Troubleshooting isn't in the syllabus anymore. However, what could happen is in the exam, it could pop up with a network with switches and routers and ask you to troubleshoot it. So I have left a little bit in. The first command when you're trying to troubleshoot a network in the exam is the show IP interface to see if the interfaces are down or up. If the interface is down, we've got to work out why it's down and how to bring it back up. It could be that there's a cable issue. You do the show controllers and then whatever the interface name is, and you can see what type of cable is attached. In the exam, the classic thing is it's missing a clock rate, or it could be a missing cable, but in the exam, obviously, you can't plug in a cable. You can no shut an interface also. Ensure the encapsulation is correct. I don't know, it's not mentioned in the syllabus, but it could still be tested. So do the show interface and then the interface name. Layer 3, ensure the correct IP address and subnet mask is added to the interface. For VLAN troubleshooting, ensure the VLAN has been configured on the port and the interface is no shut if it has been shut. These are your typical VLAN commands. All right, moving on to network access, LAN switching. Each port on a switch is a collision domain. Classic exam question. So adding switches increases the number of collision domains on the network segment. Increasing the number of collision domains is a good thing, not a bad thing. Hubs, they're not really used anymore, are in one big collision domain. They could ask you about hubs, I guess. So I've done an image here from my book, just explaining how many collision domains are created and broadcast domains. So you can see there's a network hub here. Maybe you do have one at home because it's cheap and you can see where the collisions start and end. So I'll let you look at broadcast domains and collision domains. Your LAN switch typically learns addresses. It puts them in a CAM table, which is content addressable memory. It uses decisions to forward or filter. It avoids loops as well, so it avoids traffic going round and round on your LAN, which is really bad. We'll cover spanning tree later. So address learning, broadcast frames are forwarded out of all ports on a switch. When the switch is first powered up, it obviously doesn't know what's plugged in anywhere. And then as traffic comes in, the switch will learn the source MAC address and eventually the destination MAC address, and then it will build it into a CAM table so it knows where to send the information. So it'll store the table of MAC addresses in the MAC address table. If you want to show MAC address table would be the command. If you want to see how old or how long the messages are kept for on the MAC addresses are kept, then you just need to add the aging -time command. You can change it if you want. So, that's the command I mentioned. Please note that it's MAC-address-table. Do check this because at one point Cisco changed it. They had a dash here or didn't have a dash here or somewhere. It was very frustrating, but they made a change. The switches have got 3 ways of transmitting the frame: a store and forward, a cut through, and then fragment free. These are hard coded onto the switch. I think you might be able to change them with a command. I'm not quite sure, but this is how fast or slow it can send the information and how much of the frame it actually reads. So whenever a frame arrives at a switch port, it examines the destination address of the frame, then it checks its database of MAC addresses. If the address is in the database, it will send it out of the correct port. This is known as frame filtering. If it doesn't know, then unfortunately your switch will have to flood the frame of all the other ports. So this is a capture on Wireshark of a typical frame that comes through. VLAN stands for Virtual Local Area Network. Each port in the switch can belong to a VLAN. By default, they'll all be in VLAN 1, which you would need to change as a network engineer. A router is needed to route traffic between VLANs. Each VLAN is its own network. So if you're going to be routing between VLANs, you need a router or at least a layer 3 switch. VLAN trunk links are used to carry data from multiple VLANs. So to differentiate one VLAN from another, frames are sent across a trunk link. These are tags so that the destination switch knows which VLAN it belongs to. I think at the moment this is the switch tested in the CCNA. That could change. This supports a certain trunking protocol known as 802.1q. What you need to know about that is it supports 4096 VLANs, uses internal tagging. It's an open standard protocol. There's something called the native VLAN, which I think I'll mention in a moment. It does not tag frames. The native VLAN is the VLAN that all devices are connected to by default, and it's a security flaw. It's a security hole which you need to fix. So just look out for questions about VLAN 1 or native VLAN on the exam. A trunk link is enables messages from more than one VLAN to be sent across. Although the link can be 10 megabits per second, this is a classic exam question. The minimum recommended is 100. You don't really see this anymore, to be honest, anything that's slow, but you could be asked about it. You can manually set the port to trunk, or it can be done automatically using the dynamic trunking protocol. The settings on your devices for DTP, you can have it desirable auto, desirable, and desirable trunk. One of these will be the automatic setting, depending on the switch model you buy. You can see the current default setting with the show interface, whatever the interface name and number is, and then switch port. Negotiation of trunking is on. This is dynamic auto, so this is the first one in the list. You can disable dynamic DTP on your interface by adding the command switch port to no negotiate. So I think I've mentioned VTP already. You can have a look at this. VTP pruning, not mentioned in the syllabus, but it's basically there to prevent unnecessary VLAN information being sent over a trunk link. This is not a sample configuration, but a demonstration of commands that you would need when you're configuring a VLAN, setting VTP mode. So lab this up and try these commands, but it's not an actual lab for you to configure. If you want to have any VLANs from these numbers from here to here, you need to put the switch into transparent mode. This isn't mentioned in the syllabus, but it's something they could ask. This is a typical configuration. So I've got 2 PCs, try this in Packet Tracer, a couple of switches, and I've got the interface names here. These are in VLAN 5, these 2 interfaces here. So I've basically created VLAN 5 I've gone to the interface and made it an access interface, which is basically saying there's a device connected. Switch port access VLAN 5 puts it into VLAN 5. This interface here, I've made a trunk, so this could pass more than one VLAN information across. You can have a voice VLAN and a data VLAN on the same switch interface. CDP must be enabled. This is in the exam, voice and data VLANs, so just you need to know this bit. I mentioned native VLANs. IEEE defined it to provide connectivity to old 802.3 ports that don't understand VLAN tags. VLAN 1 is the native VLAN, and all interfaces are in there by default. Spanning tree protocol, this is the IEEE number. So spanning tree protocol was created to provide path redundancy while preventing undesirable loops. Before we had this, we had a lot of loops and problems on our local area network. Spanning tree protocol uses BPDUs, Bridge Protocol Data Units. These are received by all switches, and then this determines your spanning tree topology. So we'll put a port on a switch in forwarding or blocking state. Forwarding ports provide the lowest cost path. So this is basically the best way to get. And it decides the lowest cost path to the root bridge. So this is like the boss. For example, say this is the route. This will be the boss network from the local area network. Some ports will be put into blocking state. And the reason is it will prevent frames on your network from going round in never-ending loops. So it goes to this switch, to this switch, to this switch, round and round and round, and eventually your network will come down because of too much traffic. You could force the network will use spanning tree to choose the root bridge, or as a network administrator, you can force it by configuring increments because it's hexadecimal in the calculation, increments of 4096. So the command is spanning tree VLAN, whatever the VLAN is, and then the priority. So you could have a different route for every VLAN if you wanted. Or you can use this other command, spanning tree VLAN. Primary, you can also choose the secondary command. This is mentioned in the syllabus. Ports that are participating in spanning tree, they can be in one of 5 states: blocking, listening, learning, forwarding, and disabled. Only in the forwarding state is user data actually sent on the network. These are just to determine what is the best path for the traffic to take. Port fast is in the syllabus, which is why we're mentioning it. It's typically enabled for a port or interface that connects to a host. When the link comes up in this port, the switch skips the first stages of the spanning tree algorithm and directly transitions to forward state. So it's basically for speed. The command is spanning-tree and then port fast. For spanning tree security, we've already learned about port fast. An important fact is that a port fast switch will keep listening for BPDUs. Classic exam question. So if someone adds a switch to a port, say for example there's a PC connected to your port that's got port fast, somebody swaps it out and plugs in a switch, then it's going to bring your network down. So to guard against this problem, Cisco has provided BPDU guard, BPDU filter, and root guard, all in the syllabus now as well. This is used to protect from spanning tree domain from external influence. So if it's enabled, if there's a BPDU, which means it's a switch being plugged in, it will bring the interface down and put it into error disabled state. This is the command to configure it. BPDU filter. If it's configured on a port that's got port fast, it'll prevent the port from sending and receiving BPDUs on that port. This is the command to enable it. Loop guard is a STP enhancement. It protects against layer 2 forwarding loops by monitoring non-designated blocking ports for BPDUs. Root guard is configured per port, as with BPDU guard. It monitors for incoming BPDUs. It prevents a port from becoming a root port. Now you could actually configure RSTP, which has a lot of these things built in. Rapid Spanning Tree Protocol. This is the IEEE number. It basically speeds up convergence on your network. So spanning tree can take 50 seconds, which is an absolute lifetime. RSTP takes that down to 2 seconds. If you want to configure it on your switch, it's spanning-tree mode rapid-PVST. I mentioned extended VLANs already. Ether channels. An Ether channel is comprised of a physical, individual, fast Ethernet or gigabit Ethernet or 10 gig Ethernet port. They bundle all these ports together into a single logical link. Each Ether channel consists of up to 8 ports. Check on the documentation for your device to see how many are supported. It does have a protocol that runs across these ports that are put together. You can choose between PAGP and LACP. PAGP is Cisco, LACP is an IEEE standard. Just note the MAC addresses that are used for PAGP. I think this would be the typical thing they would ask you. Switch channels using PAGP are configured to work in one of 2 modes, auto or desirable. The best thing to do would be to lab this up if it's supported on packet tracer. LACP is sent to the IEEE 802 slow protocols multicast group, and this is the MAC address that you would need to know. It does ask about routing on your VLANs. So you need to know about switch virtual interfaces. SVIs are logical interfaces that represent a VLAN. It's not automatically configured when a layer 2 VLAN is configured on a switch. It must be manually configured by the administrator using this command here. If you want to configure a switch virtual interface, I think you may need a layer 3 switch for this. Just check on your documentation. Here's a sample configuration. So pause the video if you want. I didn't write the topology down, but basically practice this configuration. IP connectivity. So routers must have some means of learning networks that are not directly connected. The show IP route command provides information regarding your routing table. You need to be familiar with this command and all of the meanings for it. I'll just go through that in a moment. And the information that the networks can be reached. For example, the network, the routing protocol, the next hop address, and which interface to go out of. So some protocols will use a topology table that contains alternative paths to the same network, which could be used should the main path fail. So if you configure routing on your network, or even if there is none, if you use the show IP route command, all of this is your ledger for what the possible outputs are down here. So for example, it says R, so you know that means a routing information protocol. D, ERGLP. O is OSPF, E2, so OSPF. And then E2 is external type 2. So all of this is listed in a key. And then it will have the network and the metric. Each protocol, again, has got a different metric. So you need to learn these, the administrative distance, which I'll come to in a minute, where you learned it from, when you learned it, how at what time or how long ago, and then the interface. So configure some routing protocols, obviously, especially OSPF, which is mentioned in the exam. It does mention prefix matching as well. It may give you an example. So routers use the longest prefix match rule when determining which of the routes to place in the routing table to forward traffic to. The longest prefix is basically the most specific route. So if you look down here, if we're looking up a packet that needs to get to the address 1.1.1.1, the order is based on the longest prefix match lookup. So if you look here, it's got the IP address in full with every bit matching. This is the network. This would be second preferred to any device on the 111 network. Then this, and then a route to any network. Static routing, you do some labs on this, but basically you would do the command IP route to this network with this subnet mask, and then you could do the next hop address. If you don't know the next hop address, say for example it's your ISP, sorry about my writing, then just say send all of the traffic out of this interface. IP default gateway command, they could ask you about this. It's only used when IP routing is disabled on the Cisco router. I've only ever seen this once in many years. There's an IP default network command, so this is the gateway of last resort if you hear that on the router. If you want the router to use a route, if your routing protocol fails for whatever reason, you can install what's called a floating static route. This is in the syllabus, and you add an administrative distance, which is higher than that of the routing protocol. So say, I'm guessing I was using OSPF here. The administrative distance, which is how believable it is 110. If OSPF fails for some reason, you can add this number on the end, so the network traffic would still be routed. Distance vector protocols, they aren't listed in the actual syllabus, but I think you need to know what they are just in case. So distance vector protocols understand the direction and distance to any given network connections. Algorithms calculate the cost of the connection and pass the information to every neighbor router. A couple of examples are RIP and IGRP. I guess learn these just in case, again, they come up in the exam. Link state is more likely to be asked now because this is in the syllabus. Link state protocols have a picture of the entire network from link state advertisements and link state packets. Once these have all been passed, only changes to the network are sent out. So distance vector send out your entire routing table. Even if there hasn't been changes, link state only if there's a change. Routers use administrative distances to determine how believable. The smaller the number, the more believable. So if a network is directly connected to an interface, it's most believable. Static hop, you would have configured, and then it gets less and less believable up to external ERGRP. If it says 255, then it's the packet's going to be dropped. Routing protocols maintain a table of networks and which interface they can be reached by at a basic level. And BGP is an external gateway protocol. This connects autonomous systems, which is a grouping of networks. Passive interface is useful. This is used, I think, on every routing protocol to disable routing updates on the interface. Inter-VLAN routing has been tested over many years. So this is routing, obviously, between VLANs. You can use the layer 3 switch with the SVI. So the SVI is your switch virtual interface, which you would add an IP address to. So it's not specifically mentioned in the exam, I don't think, but they do allude to it. So I think you do need to know it. I've added a configuration down here. I don't think I've put the topology. Oh, I did. I've done a topology here. So trunk port and then configuring it on this interface here. So practice these commands just in case you're asked. OSPF is the only protocol now mentioned. So they don't mention RIP, ERGRP, etc. Here's a few facts that you need to know. And I've been asked about who invented it for some weird reason in the past. So just learn all these. Which is on the Cram guide. A few terms you need to be familiar with for OSPF, your link state database, area border router. Router ID is important to know also. And this is the calculation for the best interface to send the traffic out of. So I think you'll need to know, unfortunately, you need to know these as well. OSPF has network types depending on the type of interface. For example, I'm not saying frame relay is used anymore, but it does work on frame relay, a point-to-point, a point-to-multi-point interface. And then OSPF maintains 3 tables, your neighbor table, database, and your routing table. OSPF networks will have a designated router. So this is the router that's controlling what happens on the OSPF network. It chooses based on the highest router ID. The router ID you can manually configure. You can add it to a loopback network or loopback address on your router, or you can just let OSPF decide. There's also a backup designated router, which will be the second highest router ID. Here's a configuration for OSPF, the network. You can see this uses a wildcard mask. You must always have the area as well, and at the very least it would be area 0, which is the backbone area. Note the wildcard mask must match the subnet you are advertising. So if you have network 192.168.4.0, then this is what you would advertise, including the wildcard mask. 192.168.4.0. Don't make the mistake of just advertising the standard network address. First hop, redundancy protocols, FHRP. These are the provide protection from default gateway failovers by providing a backup router. So in the event of a failover, the backup router takes over the place of the active router, providing redundancy. One of the protocols is HSRP. It's enabled by default on Cisco routers. Version 1 is enabled by default. HSRP version 1 restricts the number of configurable HSRP groups to 255. They communicate by sending messages to this multicast group on this UDP port. Again, classic exam question. Version 2 uses this multicast address, and it sends hello packets to here, which is used by version 1 also. UDP port number remains the same. In HSRP version 1, the layer 2 address used by the virtual IP address will be a virtual MAC address comprised of here and then the XX here, which is the HSRP group number. Obviously, it makes more sense when you actually configure it. In order for a gateway with a higher priority to assume the active gateway functionality, the router must be configured for preemption. So this is a configuration for preemption. VRRP is similar to HSRP, but it's an open standard. This is the RFC. VRRP sends the advertisements to this multicast address, and it uses this protocol number. The other one is GLBP. This has an active virtual gateway. The other two don't. The AVG is the gateway that has the highest priority value in the event that the priority values are equal. IP services. Network address translation converts an address from the inside of your network to another address on the outside of your network. Most commonly used to convert a non-routable address to a routable address. For all configurations, you must tell the router which is the inside address and the outside address. Static NAT is one IP address to one IP address. For example, this is the command here, and it converts this one address here to this one address here. Dynamic NAT maps a number of internal addresses to a pool of external addresses. So, for example, there's 10 addresses here with this subnet mask, and this is the configuration just down here. Finally, NAT overload, which is used most commonly, or port address translation, maps one or more external addresses using port numbers. Here's an example of the configuration. You basically turn this same set of commands here, but you add the overload command to tell the router that you're using port address translation. QoS, quality of service, lets you manage scarce bandwidth so you get the most out of the bandwidth. The default behavior is verified using the show MLS cross command as shown here. You've got three broad delivery models for QoS: best effort, which is the default, integrated services, and differentiated services. I'll let you read about that in more detail if you want to pause the video or read. Policing is mentioned in the syllabus, so ensure that you're familiar that policing is used to compare the ingress and egress traffic to the configured policia. SNMP is an application layer 7 protocol, uses UD ports 161 and 162. It facilitates the exchange of management information between network devices. You have a management system, agents, and then managed devices. And these basically monitor traffic on your network for configurations and any errors. An SNMP agent resides on each managed device and translates the local management information data, such as performance or errors. When using SNMP, managed devices are monitored and controlled using 3 common SNMP commands: read, write, and trap. The read command is used by a network management station to monitor managed devices. The write command is used to control managed devices, and finally the trap is used to report events. You've got 3 versions of SNMP. Each one is an improvement on the other. The SNMP provides 3 additional security services that aren't available in the other 2. Message integrity, authentication, and encryption. And again, this is your classic exam question. Here's a configuration command for SNMP if you want to try it out. Security fundamentals. There's some questions about general security management and user training, which you can read about in your CCNA guide. Switch and router security. You can add this command when you've got passwords on your router and switch. It's a very weak level of security that's easily crackable. You get from user exec mode, which we discussed at the beginning, to privilege exec. You can protect and enable mode with a enable password. Enable secret encrypts passwords. Use one, so use an enable password or an enable secret. It's a better level of encryption, but it can still be cracked. If you want to allow telnet access to your router, which we don't recommend, you can protect the telnet lines, which are called VTY lines, with a password. If you want to permit SSH into your telnet lines, then you have to add the transport input SSH command. And there's a couple of configuration commands you can add here. You can add switch port security to your switch port, so we recommend you do. You have to manually enable it. It's on an access port, so not a trunk port. Switch port security, then you type it again, and you can choose which type of port security you have, and you can make it learn a MAC address. So the first MAC address that's learned, sticky means it retains that information of the MAC address. You need to know what violation actions happen depending on which type of security you've got on your switch port. Protect mode, shutdown mode, and restrict mode. So this is another classic exam question, and you need to know when SNMP traps are sent. Access list. This is a classic exam question. You've either got to answer the questions or configure it. You basically need to know the ranges. So 1 to 99 are for standard simple access list. If you want more configuration options, for example, blocking port numbers, you'd use 1 to 100 to 199. There is an expanded range in the unlikely event that you run out. Standard access list, check only the source address of the packet, and it permits or denies the entire TCP suite. Extended, you can deny port, protocol, source, or destination. This is an example of a extended access list. And then if you want to make it easier, you can give your access list a name. This is the configuration for standard or extended access lists, and they've been given a name. So we've got a sample configuration here you can try out on your Cisco packet tracer for extended, standard, and named. Wildcard masks are applied for OSPF and for access lists. It's basically an inversion of your subnet mask. So if the number is 255 here and your mask is 192, you would take this away from this number and that would give you the result. So your subnet mask is 255.255.1920. Your subnet mask would be 0063, which is taking that away from 255, and then nothing away is 255. Syslog daemon or server is listens to syslog messages on your network. You cannot configure a syslog daemon to ask a specific device to send it messages. It uses UDP, so data packets are unsequenced. I think the only thing you need to know is which level matches which number. So 1 for alerts, 2 for critical, errors, warnings, and so on. Access layer threats. 802.1x was in the CCNA syllabus. I can't see it there now. So you decide whether you want to learn it, configure it, or take a risk and not look at it at all. But I have described here what 802.1x does. There's a lot to it, and it's pretty tricky, to be honest. But it may be worth just learning what's in the Cram guide. DHCP snooping is on the syllabus. This provides network protection from rogue DHCP servers. So basically somebody's trying to hack your network and give IP information to devices and then take control of your network. So this divides your network between trusted and untrusted hosts. When it's enabled, the switch builds and maintains a DHCP snooping table, which is also called a binding table, and it prevents and filters untrusted networks. So here's the configuration, which I think you would need to know for the exam, and try it out on your switch. Dynamic ARP, I think, is mentioned in the syllabus. It's a catalyst switch security feature. It validates ARP information and determines the validity of packets by performing an IP to MAC address inspection. So this stops somebody basically capturing traffic. AAA is in the syllabus. Authentication is used to validate the identity of where it is. That's the first A. The second is authorization, determines what that particular person can do. And then accounting provides an audit trail. So AAA uses standard authentication methods, which includes Radius and TACAX. Kerberos as well could be mentioned, although it's not in the syllabus. Once your security server has received the credentials, it will give a pass or fail. Radius uses UDP, classic exam question, port 812 and 813 for accounting, which, unlike Radius, is a open standard protocol. TACAX is a Cisco proprietary protocol. Again, just a typical exam question. If you're on an enable AAA, you use the command AAA new dash model. Final few bits are on automation and programmability. The software-defined network aims to disassociate the decisions about traffic flow from the systems that forward the network traffic. So this is a new paradigm of networking where you decide what you want your network to do, and then the software-defined networking software takes care of all of the decisions for you, so making it a lot easier. They do use APIs, which is application programming interfaces. So the southbound API, this is in the syllabus. This relays information to routers and switches. OpenFlow is the first to market. The southbound interface allows the controller and network device to communicate. Different types of controllers, which you may need to know about. And then northbound APIs are used by the SDN to communicate with applications and business logic. So I think you need to know the difference between these two. Network devices are equipped with the data plane, control plane, and management plane. Again, I think these are specifically mentioned in the syllabus, and I'll give you a definition of the data plane here, the control plane, and then I think the management plane is used to manage the devices, for example, SNMP. REST, not sure, that was in the syllabus. I'm not sure if it still is, actually. Oh yeah, REST-based APIs, so there we go, still in there. RESTful API design is designed to leverage the existing protocols. It can be used over many protocols. It takes advantage of HTTP when used for web APIs. The 6 key constraints for the REST API design to be aware of when deciding if it's the right type for your project. I think basically just learn these. JSON data is written. You may well be shown some data and asked to confirm which is the correct type. It's written in name value pairs. It consists of a name field in double quotes, followed by a colon, followed by a value. JSONs can use arrays. These are a type of string, number, object, boolean, or null. So here's an example. Configuration management tools, they include SaltStack, Ansible, Puppet and Chef have been removed. Terraform has been added. If they add something new, you're more likely to be asked about it. So just learn what Terraform is. AI is a new one as well. So this is classically going to be asked. Machine learning, it's a subset of AI that enables systems to learn and improve from data patterns without explicit programming. Predictive AI, this is uses machine learning algorithms, analyzes historical data and real-time data for forecasting future events. And then generative AI, we've all used, it creates new synthetic data or configurations, such as simulated network scenarios, also used for creating images. All right, so that's down and dirty. There's a link along the videos I'll put up so you can download this. If you want to pass your CCNA, this is a good book. It breaks it down into 60 days. Some of the books would help you pass your Cisco exams. I've got some websites there as well that will help you pass exams. And best of luck.